Hello and welcome back to Adult Programming. Today we're going to pick up from where we left off a few days ago. And where was that? Let's see, we containerized our classifier and we ran it on Minikube over here to make sure that instance is off and not running for the past couple of days, looks good. And then we saved all that information to our JSON file. So we have classifications from our model for every asset ID, I think up to 50, for every bird in our 105 Florida birds. Okay, so what are we going to do with that today? I think we should go back through to the training data, and as we were writing that training data, maybe instead of using 10 files, we allow it to use 25, and we take into account this model's predictions. So that way, if a segment was properly predicted, then we use it for training data. If not, then we trash it. So that way we're using valid data, or at least as valid as possible, for every iteration, for every example in this next iteration of this model. All right, another thing that we're going to do is instead of using like a bigger 512 spectrogram width, let's chop that down to something like, let's see if we can do it in half, 256. We're going to chop it down to 128, like a quarter the size. Is it 196 would be the middle there? Let's use 196. And the idea here is, before we were filtering down the audio into bigger chunks, and now we think that we have better training data, so we're going to filter it down again into smaller chunks to find the actual pieces that are valid bird sounds. Because that big chunk is like 10 to 15 seconds. I need to figure out an exact figure for that. It's our NFFT amount, like times the sample rate, something like that. I don't know. We'll pull the notebook and look. Anyway, the idea of what we're doing now is we're going back through and creating smaller windows in our training data and only using valid training data. So let's go back to the beginning, and for this we do not need a big heavy box. So we're going to drop it down to 2 by 8. We might scale it back up here in a little bit to actually make that training data, but for now we're just going to look at the code and see what's going on. Yeah. So our instance is saving the new CPU size, and then we're going to turn it back on and take a look. All right, our box turned on. So let's log in, start Jupyter, and check out this notebook. So we're going to scale it down to smaller window sizes, and we're going to filter that training data based on our model's predictions that we just made a few days ago. So we're going to start with notebooks, and where do we make this training data? It was in spectrograms. I think it was here. Yeah. Where's our import for? There it is, TensorFlow. Okay, so this is our training data. Training data creation notebook. We're going to rename it as training data. Let's see, so what are we going to change here? Our width. also of seeing exactly how many seconds are we talking about in one of these ranges. So let's look at our spectrogram creation loop. It's right here where we're going through the audio data. So we're going from the beginning to the end of the audio data, and we're skipping by W divided by 2 each time. So each segment, right, because then when we're creating it, we're actually saying though I plus W. So each little frame includes 2 half W's. Am I saying that right? We do know if we went through a range and we grabbed 512 frames, how much audio data is that? In 512 frames, we've skipped over it 256 times. Right. So it'd be 8 seconds is where we're currently at. And then if we're changing this down to 196, down to 3 seconds of audio. I like that. Sounds much more practical. I mean, most bird calls are 3 seconds. There are some, that go on and on, but it's like a repetition of the same thing. And so maybe if you had 2 species that one did that for 3 seconds, one did that for 5 seconds, we're going to lose them here. But the majority of them should be caught there. And most other bird calls, like 3 seconds is a decent bit of audio. So let's do that. And if I was wrong in those calculations before, let me know. Doing this on the fly, so I'm going to be wrong sometimes. Okay, 196, and we said that's about 3 seconds of audio. Skip, let's see. Let's change that down to 128. So we have an overlapping window a little bit, but not too much. 98. We do half windows. Same Florida birds. Same download and wave, same spectrogram. We'll go ahead and remove our old spectrograms. We don't need them right now. But there's something that we do need in here. So what we do have right now is we have 2 different window sizes. In our scores file, our windows are based on that 8 seconds. And here we're going to be doing our windows based on, what would you say, 3 seconds. So we're going to have to kind of put a little bit of index checking in here. And where are those files? We ended up saving them to, it's just the root folder, wasn't it? Out scores.json. There it is. Let's take a look at that real quick. Scores equal JSON load open scores. And then what was this? A hash, right? So we just, let's look at a few keys. Because we're in the notebooks. One more down. Ticked object is not callable. Oh. That's not going to work either, is it? There. There's our scores. And each one of these windows represents 512 units into it, and we're skipping by 96, 96, 98. Yeah, because 98 times 2 is 196. Okay. So when we're doing this, we're going to be doing it here. We're going to say asset scores equal scores asset ID. And then we're just going to skip making the spectrogram here if that score was not the correct index. The index that we're looking for is right there, bird index. Okay. So what we just have to find is what index in the score is our current window at. Right. So where are we looping? Looping here for asset ID, and we're going to say score index. So original one's going to be 0, and then here's where we skip by skipping. Skip by our skip amount. So what are we going to put here? Our window index is that. So for every 512 divided by 98. In favor of making this cleaner, we're going to change that to 128. So then 512, 128, 4. So every 4 of these. So if window but if we're looking at 0, 0 would come across as that, right? So we actually need to start our score index there. That makes sense. We're going to start the score index at -1 because the first time through our score is going to come up. Our first window index will be 0, and the remainder of 0 divided by 4 is 0. So our score index will increase because of here. We actually have to check if the asset scores for this score index don't equal the bird index, then trash, or continue. Okay, that should do it. How long is this going to take to run? Just moving some things around so that way it looks cleaner a little bit. It's still a little messy, right? Like, what's going on here? This is where we're actually doing this. Before I use 16 cores. I wonder how long that took. And here's our TF records. Okay, so let's go ahead and turn off this box, turn it back on as the 16, and then we'll loop through this. So I'm gonna Control S and make sure it's saved. Because Jupyter sometimes gets, you have a local copy, you have a saved copy. You can get into places where you accidentally close it and you never save the local copy to the actual box. I don't know. On to 16. Okay, now we got a 16 core box here, 60 gig of memory, and we're going to start that. And then when it boots up, we're really just going to start it on a loop to go through all of that training data and filter it out based on our previous predictions. And the idea is just to filter this down so that we have better training data And we've also shrunk the windows so that way we are being more precise in where we are making that prediction. Because we're probably going to loop back through this entire cycle again. So after we create this training data, we will create a model from it. If that model is accurate enough, then we'll go back through and predict all of our training data again, and see what's different. See if we can narrow down actually where those bird calls are at. I have one concern going on, and that's, I'd mentioned before that we're going to increase the number of files that we're using for this iteration, because we're going to be taking away some of the data because we're filtering it down, right? But I don't know if the model's overfit at all. Like, we've only used those first 10 files, and I don't think we ran it long enough to overfit it. But and that's kind of the point, a little bit to overfit it. Anyway, what I'm getting at is I don't know how accurate it would be on files 11 through 25 versus 1 through 10. So at some point we should probably go back and take a look at that. I just started screen, didn't I? Yep. Okay, Jupiter. Jupiter Station, we have arrived. Notebooks, Untitled, where are we at? Create training data part 2. So you probably saw it before. This is going to be a really similar thing that we did on the first time around, except we added in that check for the scores. So we're just importing the most important parts here. Actually, not even at this stage. Next, we're going to create the TF records. Right now, it's just Yuki for the spectrograms, the fast Fourier transforms, wave file, multiprocessing. We're bringing in pool, so that way we can use multiple cores here in parallel process. Anyway, our functions to download the wave, use FFmpeg, convert it to an actual wave, because we're downloading it downloading an MP3, and we have to convert it to a wave, mono channel 16K, and then the spectrogram from it. So we're going to go ahead and delete our spectrograms folder here, recreate it, go back through here, and process all that audio file. You know what? We never changed that max files up. Let's do that. Okay. So we're going to go up to 25 audio files per bird. You ready? Here we go. And it errored. Fantastic. Invalid syntax. Nope, not that one. Where's it at? Non-equal bird index. There. So I couldn't find it because there was no if. There we go. Boom. And we air it out real quick here again. What was our error? Score index not defined. Score index not defined. What is this? It's me standing too many feet away from my monitor and seeing an equal sign as a negative, or a negative as an equal sign. Okay. There we go. Start up with these birds. 8, 8. And really it's just a bunch of random output right now because they're all printing at the same time. Usually I add a sleep statement in here, so it sleeps a random amount of time per loop, or after each thread started. So the output looks a little bit more readable. But anyway, it's going. We can see over here. There we go. If we run top, how many do we have running? They're not running. Did it error out, or what's going on here? Tell you what. We're going to stop the whole thing. And restart it. Multiprocessing can be picky. There's no harm in stopping and starting your kernel again. Just make sure that everything's valid. There, another error. No such file or directory. Oh, you know what I never did? Whoops. Sorry about that. All my fault here. All my fault. Oops. Do you know what we did? We didn't mount the data directory. Now we did. So, if we run this again, restarted it, so, and I know there are buttons you can run every one above this, but there's something nice about just seeing every little box run. Little checkpoints in your code. That's fine. You know what, I'm going to go ahead and add in that sleep statement here. So next time I run this, all the threads won't start at the same time. There. But I believe they're all running again. Let's... And they're not. Why isn't everything running? Maybe it is and it's just not taking processor power. I don't know. I have something wrong in here and I'm just not seeing it. Tell you what. Let's run this loop individually. Just for one. Only size 1 arrays can be converted to Python scalars. Time.sleep. Whoops. Local variable score index reference before assignment. Mother. There's another typo. Again, because I'm standing like 2 feet away from my monitor. Asset scores is not defined. Another typo. Whoops. Here we go this time. Maybe. Maybe. Nope. String index is out of range. Asset score. You shouldn't be a string. What? Oh. It should be a string. You know why? Because we saved it as a string. We never parsed it. It's not dump. What is it? Is it load? Oh, doing it wrong again. It's not even JSON, is it? It's not JSON, it's just a CSV. That'll work. Well, you know, maybe. This index is out of range. What's our score index? Should be... What's extra fun here is that what I'm making is use new score index 2 plus equals 1. Oh, I never had the negative there. It's fun whenever I'm making stupid mistakes now, right? Like, you always make stupid mistakes, or at least I do. But right now they're on camera, so unless I go back out and edit this, you're going to sit there for like 2 minutes and look at it and be like, wow, why isn't he fixing that line? It's not an equal sign. Why doesn't he use this editor with this type of output? That would really show this. You know, whatever. It works now. It works now. So I took out all that logging. Keep that. What else do we need to have in here? We're going to let it run here. Not invalid training data. What do we call this? Filtered. Below score threshold. It's kind of boring. You fail. And then we'll put in the index. On second thought, we're going to remove all this. We're going to see that it works at the end, and we're not going to have that much output here, because that would be a ridiculous amount of code, or amount of logging coming into the browser. Okay, back up to our pool. We're going to save this notebook. We're going to just restart the whole thing. Why don't we see output yet? Because everything should be sleeping some form of 10 seconds. There we go. I wonder if everything slept the same 10 seconds. I don't think so. Kind of looks like it though. Oh well. Oh, we're starting there. Alright, so finally, let's look at top and see 16 processors all working well. Boom, boom, boom. Got 2 more left to jump in there. There they go. There they go. And if we look at our data and spectrograms, nope, none there yet. you have spectrograms made. Uh-oh. Crap. We don't have any spectrograms written yet. So does that mean that everything is skipping? You know, when I pressed record this time, I really thought like, wow, I don't even know if I'll have like 2 minutes of stuff to do a video. We're just going to start this and go. Whoops. Whoops. Oh, wrong block. Wrong block. There we go. But if it fails, I also would like to know these things. Gotta go forward, gotta go back. No, no, no. Let's see, 0, 93, 93, 0. And 1, I think 1 is the bigger file. And this is what we looked at before, right? So 1 has a lot of yeses, they should, and they don't. They don't. Why don't they? Why don't they? Class? Anyone? Anyone? Bueller? Yeah, you're right. Exactly. Should we do it here or should we do it up there? We'll do it right here. It'll be cleaner. Do you know yet? There we go. Yep. Whoops. So again, we know the first one doesn't work and the second one does. Or, you know, it should. This is a good, like, little check for us, right? And this is why it's okay sometimes to skip steps, but sometimes it is not. Look at those pretty spectrograms. Should we print one out? You want to print one out? Let's print one out and see what it looks like. What are we going to do here? We're going to say, you know, our data, and this data is all stored as like a CSV, I think. Yeah, it's just one long CSV value. So, say spectro. Just when I thought I was going to end this video, you know, open. Let's see. We need to map the integer and split it by CSV. We're doing the exact same thing we're doing above, right? So we're doing a list. Really, we're going to turn all this into an NP array anyway. So NP dot array. Again, skipping steps when I really shouldn't, but whatever. Open data spectrogram 0 0 dash 1 dash 0 dot spectro. Okay. Dot read dot split. Does it work? Nah. I spelled something. S-P-C-T-R-O-G-R-A-M-S. Added a 0. Check that out. What do we do next? We go PLT, is it mshow? Node syntax, spectro, oh, 2 dots there. Oh, cannot reshape that into that. That's weird. Oh, because these aren't 5112, are they? That was the other ones. This is 196. There's our spectrogram. Pretty, right? Pretty. Let's take this code, put it there. For I in. So where are we going up to? 0111. Instead of what, 24? Boom, 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 boom. Look at those pretty spectrograms. So that's all of our training data. That's what it looks like. We can go back here and make some images from here if we wanted to. Right, like each time we could actually go through and have NumPy save that to a PNG, and then we always have reference values to what that training data looks like. But anyway, getting back to the main event here. Let's stop this kernel, because I think it's still writing values. It is. Stop, restart. Change that. Get rid of our logging. There's 1, 2, 3, and 4 makes 4. What are we going to see here now? Look at that. And if we do recursive and looking at all of our directories, there are some spectrograms showing up. So it's working. And we can also see all 16 processors working because, you know, that's fun. So now that this has gone on for how long? 25 minutes. 3 to 5 minute video that took at least 5 times that. Well, there you go. That's how you use a model to filter out your training data. Yeah. Maybe we'll come back real quick after this and run this last box here that will create it into TF records. You know, maybe. And then we jump back over to training, train a model with it just like we did before, and boom, boom. So.